Now, finally, quickly going through process C and S. So process C here is demonstrated by these cyclical changes. It gives us the alertness throughout the course of the day. So you can see that this is the time period of sleep. During the day, you could see that you get more alert, and during the night, you get less alert. Now, process S, or homeostatic process of sleep regulation, is more sensitive throughout the course of the day. So as you're more active, you start to get more and more tired. And then at some point, you have an accumulation of some kind of metabolite that then leads to this increased sleepiness that then subsequently meets up with this sleep threshold. And this causes you to go to sleep. And so when you go to sleep, then metabolite or your energy sort of metabolite gets reduced and your energy increases. And it's that ultimately you reach the waking threshold. And so you reset through the day. Now, if you take a nap, those metabolites can reduce. And so when you go to sleep, you're able to as well go to sleep, but then it meets this waking threshold a little earlier. So you could potentially wake up earlier. Now, if you also do an all-nighter, you have the accumulation of metabolites. And so you're way above the sleep threshold. So you're going to be feeling sleepy throughout the day. And so what are those homeostatic mediators? There's plenty of evidence to suggest that adenosine is that mediator. It's a byproduct of metabolic activity. It rises during the wake and falls during sleep. And it influences our sleep regulatory parts of the brain, which is the VLPO. And caffeine basically mediates the activity through adenosine because it competes with the adenosine at the A1 receptor. So you're feeling less tired because the brain's not sensing the adenosine. Cytokines can also affect the process S. And this is why when you're sick, you produce these cytokines that then subsequently affect the VLPO and cause you to feel more sleepy. I want to quickly show how sleep homeostasis works, particularly during and after sleep deprivation. So in panel A, we see the percentage of non-REM sleep across time. And so during the normal baseline day, you have non-REM. So this is during sleep. You see the non-REM percentage high, and then when you wake up, the non-REM percentage decrease. And you can see that slow wave activity sort of stay the same. However, if you're deprived of sleep, and then you go to sleep again, there's a little bit of a rebound effect. And process S mediates this. You can see that the non-REM increases, particularly the slow wave activity is increased right after you go to sleep. So it's a way in which our body compensates for the sleep debt that occurs. And which hormones are associated with process S? This is an interesting study that did hypnosis before a nap. And then there's a control group who didn't get the hypnosis. And there was a number of data that were recorded across this experiment. And you could see here that the slow wave sleep in those individuals who got hypnosis got a greater quality of sleep. So they got more slow wave sleep and had a deeper stage of sleep according to S4, S, and 3. And then you could see that the corresponding changes. So you have an increase in growth hormone for those people who got more slow wave sleep activity. And you also had increased prolactin levels as well, whereas cortisol really didn't have any changes. So the hormones that are associated with the process S is growth hormones and prolactin. And so to distinguish the process C and process C is an anticipatory process. It affects nearly all the tissues. Remember how melatonin, cortisol, and temperature affects all the tissues. And what it does, it primes the terrain for the next stage of diurnal activity. Process S, on the other hand, is reactive. It affects very specific pertinent tissues, like growth hormone doesn't affect all tissues of the body, and it responds to the prior state for optimal restoration and growth. So if you've gotten sufficient nutrition in the previous day, then the growth hormone, if you're trying to grow, will be more active. Or if you are sick, then you'll get more sleep as a result of process S. And so the hormones responsible for process C, melatonin, cortisol, and through cortisol, ADH, and the renin-angiotensin system. Hormones for process S involves growth hormones, testosterone, prolactin. And then the autonomic nervous system for process C sets the baseline rhythm. And for process S, it modulates the phasic shifts. So PNS is maximal during the non-REM sleep. And so the key synthesis here is that process C sets the scaffold and process S superimposes state-dependent modulation. So these are the how these two interact with each other.